Gentili signore, egregi signori, dear ladies and gentlemen, dear professors, care amiche e cari amici del Monte Verità, benvenuti.
So welcome to everybody in a special way to the audience come here just for this event. The scientific community involved in BioM spending some days here in this really fantastic location to evaluate the present data and the future research strategies. In this context, the organizer planned these public events to diffuse the results obtained in the framework of Seawind project, founded by the DG Research of the European Union in the framework of the 70 Framework Program. Seawind means sound exposure and risk assessment of wireless network and devices. We will have 5 presentations, one from the Professor Nils Kulser, is the coordinator of the project, 3 for Professor Back-Andersen, Martens, and Schar. They are work package leaders in this project. And finally, we have the presentation of the Dr. Melnik, is one of the external advisor of the project. And finally, we started the discussion, of course, open to the audience. So I'd like invite Nils to start.
Thank you very much for this nice introduction. Good evening, everybody. We are pleased and thankful to the Monte Verità to give us the opportunity to summarize the findings of this project. This is the first time we do that because the project ends at the end of the year, and we are in the phase of summarizing what we found. So what already has been said, Seawind is a European-sponsored research project. It stands for Sound Exposure and Risk Assessment of Wireless Network Devices. It's a cooperative and interdisciplinary effort of 9 institutions, the logos of which are shown here. We will hear more about them shortly. We also have the European coordinator here who is responsible for this project. Otherwise, all the project leaders from all these institutions are here, except the person from Dialogic who couldn't make it today. There are several electromagnetic sources. They are the natural sources, like the Earth magnetic field, which has been used for navigation before GPS came up, but the birds are still using this to find their way. Then there's lightning. The Ticino has a big tradition on Monte Salvatore to do research on lightning, but there are a lot of man-made sources like the power networks, train, power lines, and then at the higher frequency, the sources which are used for communication, the big antennas usually on the top of the mountains, like here on Sentis. Then the antennas closer to your home, maybe not an antenna site like this, but such an antenna you find probably in your neighborhood. And then we have the devices we all are getting addicted to. Now, these antennas are bigger, and actually they have a much higher power than these tiny antennas. But nevertheless, this source is the strongest source we are daily exposed to. This movie, if it works, shows you the exposure. Because the antenna is so close, the exposure is very high. And here is shown the exposure of the brain. And if you look at the brain exposure, the mobile phone is 10,000 times stronger than the exposure you receive from base station. It's at least 10,000 times stronger. So that's why this topic was the focus of many research programs which started in the mid-90s. There were international one and national one a few are listed here. And because GSM, which is also known as the 2G system, was in the main focus. This generated a lot of literature, and last year in May, IARC, which is a WHO organization, assembled about 30 scientists in Lyon to evaluate these data, which mainly focused on mobile radiation. And then in that meeting, they categorized RF as possibly carcinogenic. We will hear more how this process works from Ron Melnick at the end of this presentation sessions. But in the meantime, new sources came up, and another sources which operates close to us are the wireless networks, data communication. So we are now using mobile phones as a data terminal. We're also using it not to do conventional phone calls, but doing Skype or video conferences, using FaceTime or Skype or others. And then we have installed, most apartments today, the houses have a wireless base station inside the house, such that we can move with our tablet or computer to any room and work there. Then some people do the observation of babies with devices which are also based on data-enhanced technologies, or RFID are coming up to identify objects or packages. Therefore, the EU was calling for a proposal because we didn't know much about the exposure. And they wanted to improve the exposure assessment of wireless communication devices. We wanted to establish whether humans are at risk from increased exposure to electromagnetic fields from wireless network at work, schools and homes. There are multiple sources that has to be considered. There are several parts of the body exposed, not as previously the handset was dominating, exposing the brain, but now other body parts are exposed. Then they wanted also have additional in vivo and in vivo investigation and up-to-date scientific evidence-based risk assessment data on EMF and health regarding this exposure. They gave us 3 years and 3 million, which is not that long and not that much for such a complicated task. And you will hear what has been achieved. So we wanted to have a serious scientific approach, no quick political-driven answers. We wanted to have a comprehensive exposure assessment because this was the main task. We looked at the communication system, indoor propagation, measurement protocols, because it's different to measure these devices in mobile phones. We wanted to consider how children are exposed versus adults and develop new instrumentation and simulations platforms to assess the exposure. Then we made targeted in vivo and in vitro and in vivo experiment and disseminated the findings to standardizations. So we built a consortium of very competent labs and which assembled all knowledge which are required. There's a very interdisciplinary approach required. So we have the University of Aalborg, who is very specialized in communication system. Then we have ETH, University of Ghent, Aristotle University, and Schmid and Partner, who are leading labs with respect to exposure definitions and assessments. And then we needed biological groups. So we have the Fraunhofer Institute, who is a well-known lab for in vivo experiments, and the University Basel, who has an excellent reputation in genotoxic research. And then we had, for risk communication, because this also was part of the project, we had Dialogic. And we also disseminated the findings to standards, to improve the standards. And in order to have people input from the outside, so we built an advisory group consisting of Melnick and Erik Van Rongen. Both have very large experience in handling such research efforts. Build it as we do as a researcher, divide the task in work packages. I don't want to go through that, but summarize what you're going to hear today. So Professor Jürgen Bach-Andersen will talk about the communication system of wireless network. He will illustrate you what are the differences and the similarities of the communication system, and what is new with when we compare mobile phones to data communication. Then Professor Luc Martens will talk about how that the exposure compare to phones and base station. Then in the for the bioexperiment, Professor Primoscher will explain why we selected this set of in vitro and vivo experiments and what was found. And at the end, Ron Melnick will explain how risks are evaluated in this context and why IR came to the conclusion as possibly carcinogenic, and what does now the new results change with respect to this assessment. With that, I want to give the podium to Professor Andersen.
Right. Thank you, Nils, and good evening. I'm very pleased to be here at this wonderful place. But I think I have a difficult task because this is a very technical session, my part. But I'll try to do it sort of superficially without being wrong. So what is this about? This is about, I'm sure that most of you, I know that most of you have a mobile phone, some of you have more than one. And this is surrounded by electromagnetic fields which are necessary for the production of the information and for transmitting it to a receiver that says somewhere else, like Niels Guster mentioned. So what are these fields and frequencies, and what are the systems, and what are the trends? So part of the goal of this project is that the biologists, they study these fields. But we have to decide first what sort of systems should we study. And this says we have done some studies of the systems mentioned here. GSM, so-called second generation system, and UMTS, which is 3G. So more, if you buy a phone today, it usually includes both 2D and 3G. Then DECT is so-called cordless phones, some of you may have at home for short distance communications. And then the Wi-Fi that Nils mentioned, I'm sure there's a transmitter somewhere here in this room illuminating us all. And then finally RFID, which is radio frequency identification systems. So the reason behind this choice is that these are the most popular ones. So it's, it's billions of people who are using these systems. And also Wi-Fi is very popular, and RFID will be more popular in the coming years. The last one here is an important one. It's called CW. It stands for continuous wave. So there's no information, just power. But this is the important reference. So if we find the biological effect from GSM, for example, or if we don't find it, and it's the same as CW, then we know that the various pulsing and modulation are not important. It's only the power that matters. And without disclosing the conclusions, I think in most cases this will be the case. Just as an example of this variation of power, this is DSM, where the power comes in a short burst and then an intermission and then burst again very quickly, sort of more or less like 4 milliseconds. So if this is yours, then other users use this, and then you come back after 8 slots and so on in the time domain. You can hear this usually if you put your phone next to a radio, even if it's not on, the radio is not on, you hear this bzzz, buzzing sound. And these are these fluctuations, or these pulses. And this is part of the study here. So the reason why these things are considered important for research is that there's some indications that this pulsing has a biological effect, and that's why we have to be careful to choose the right signals for the studies. Now this is also a very busy slide, but this is related to the comparison of DSM and UMTS, the 2D and the 3D. And the important is up here is the transmit powers. Here we can see that DSM goes up to, this is a so-called a dBm measure, it doesn't really matter, but we see that above about 2 watts or so, which is 33 dBm, and in average it's around plus 20 dBm, depending on how far you are from a base station. And this is also DSM 1800. Now the most fantastic thing is that the average value for UMTS 3D is minus 20 instead of plus 20. That means in normal numbers there's a 10,000 factor of 10,000 between the transmit power from the handset. So anybody who is nervous about the transmission, you should use the 3D because it's negligible. But for the biological experiments, we still need to use the maximum value, even if it occurs very rarely in reality. So this was one difference between the second generation and the third generation. Wi-Fi, I won't say much about it, except to point out that, as also Niels Kuster mentioned, that these will most of the time be exposure which has some distance from the head, maybe in the lab or lying on a table be next to you. So it's a little different situation. And I'm illustrating this on the next slide, I think. Yes. So these are absorbing people. The like in a classroom or a seminar, and this is a German study. We borrowed an aircraft, first-class cabin, and there's all the students there sitting as absorbers with working with their laptops. And this is an effort we're doing in Aalborg, trying to measure the radiation, how much of the power from the device is absorbed by the person. So he's rotating around, and we can integrate the power which is leaving the device and radiate out, and the difference between the two is absorbed in the body. I don't have any actual numbers today, but this will become later. So this is Wi-Fi. The actual signaling is a little different from from DSM, but still it has unique features, and that's why we are included in the experiment, biological experiments. The RFID is a technology that uses radio waves to transfer data from an electronic tag called an RFID tag or label attached to an object. And the idea is, of course, to find out what is the object, like, for example, suitcases at an airport or other devices or persons, which could be for an entrance to some system or just finding out where the persons are. So these tags will be many, many places. And there's an example here of a tag to the left. And most of the tags are passive. There's no battery, there's no power coming out from here. How do you communicate with it then? Well, this reader illuminates the tag and it scatters from, so the power comes from the reader to the tag. And that makes it, of course, very small power coming out from the tag, but the power from the reader is on all the time in order to illuminate the thing. So in terms of exposure of people, it will not be very much, I guess, but there could be accidental. I don't think you should look into this. I think I have some, this is another reader. So it's about 1 watt. The frequency is a little less than usual mobile phone frequencies, tag passive, and power, continuous power to the tag. But they are very popular systems, so we'll see them everywhere in the future. Another thing is, goes beyond the devices worn by people, but is an example of a sensor network which is becoming very popular. So all these points here could be small units placed around in a building to measure the temperature and whatnot, or it could be used as a metering. Power company reads the power and transmit it to somewhere there, so they can know every 15 minutes. So your house will be more or less turned into a network of sensors, maybe. Various systems again: GSM, UMTS, Wi-Fi, RFID, and CW. Those with an arrow is part of the biological experiments, as Primo will talk about in a minute. The reason why we didn't study DECT is that it's very similar to DSM in terms of pulsing and so on. So that's my contribution. Thank you. I hope you understood some of it.
Okay, good evening, everyone. So I'm Luc Martens from Ghent University in Belgium, and our contribution. So I have to be closer to the microphone. Okay. So the contributions which I will explain is the exposure from the wireless sources in indoor environments, and this is the outline of the presentation. So first of all, I will come back to the indoor wireless sources. Then I will try to give you some insight in the incident electromagnetic fields and how we did the measurements, which kind of devices we were using. So we will show some results of studies in schools and in creches. There are more measurements, but we do not have time to present them all today, but they will be available afterwards. I also will show you some measurement close to one access point. I think it could be interesting if you have in home an access point for wireless communication. What is the field close to that access point? And then we are not only interested in the incident field, we are also especially interested in the fields induced in the human body. Then I also will present a web-based exposure tool which will be available for the public in the world. So you will be able to access that tool, and it will be free, and you will be able then to calculate through that tool some indoor exposure. Try then to come to discussion and conclusions. So coming back to the sources, so we have first of all the digital cordless phone, as Professor Anderson also mentioned. Lots of people are using that for just phoning. It connects to a base station, and so you can use the phone throughout the home without wires. Then there's also the baby alarms, lots of times used, and especially then also the wireless access points installed in the homes for wireless communication. So how will we measure these devices? So essentially you have two devices. Maybe if you asked already a governmental agency to come to your home to do measurements, mostly they bring this kind of device. It's a handheld device, and you can walk around in the house and do measurements of the electromagnetic fields. Essentially, it gives you one number. That means it will give you the contribution of all the sources together, not only of the Wi-Fi base stations or of the baby alarms, but also from the GSM stations, from the UMTS stations, so all the sources together. These measurements are useful to have a complete field. well, a complete view on the field that you're exposed to, but you cannot say it's due to that source or to another source. It's also less accurate than a second device, and that's for the specialists like we are. So we are also doing this kind of measurements in houses in Belgium, but we are using more specialized equipment where we can then have a kind of figure, they call it a spectrum, where you can see the contribution of the different sources. For example, this is a peak of GSM at 900 megahertz, and this is a peak of GSM at 1800 megahertz. So even we can distinguish between the operators. So we could say, this is a contribution of that operator, this is a contribution of another operator. Which makes it interesting, because then you can correlate it to the sources. You could say, this field is coming from that source, this field is coming from another source. So we can measure the individual sources. Okay, you can then do measurements with these devices, but are you measuring at one point, or are you measuring at different points in the room? That needs a kind of methodology. So what is the methodology that we have done is, first of all, there's another device, it's shown here. It's a device that you even can mount on the body, so people can wear that, and then monitor their exposure during the time. So we're also using that students are having these monitors in their bags, and while they're going to the university, during their path from home to university, the fields are measured. And you can see then, for example, if they're on the bus, sometimes the exposure is higher because other people are phoning in the bus, and so you're also exposed by the people that are in the bus phoning, and so it gives you the contribution. Here we use this exposimeter. We use that just to find the variations in time. So in the school, we wanted to know, so we do measurements, for example, at 11 o'clock, but maybe the maximum is at 3 o'clock. So we wanted to correlate the measurements at 11 o'clock to the measurements at 3 o'clock. So that was the device, the use of this device. Secondly, we use this, so this is a ground plan of a school, and so what we did is, with that device, that handheld device, we were walking in the school and looked where we had the maximum value. And so once we have found the maximum value in that room, we were positioning then our complex instrument at a point, at a red point. So here in the corner, this was the location where the total field was maximum, and then we did detailed measurements here. Okay, I hope everyone is still following. So what did we do then? So I will show you the electric fields in the indoor environments. I will also compare it to outdoor antennas. So there's also exposure in the schools from GSM, TV, radio, UMTS. All the antennas outside the schools, or the creches, or the homes, are also giving fields in the schools. But in addition, you have also this exposure from the wireless stations. So we focused, because that was one of the objectives also for of the project, is to select also environments where children, because children are also using more and more wireless phones, younger and younger. And so they are also exposed, because more and more schools are using laptops in the schools, so they have to also install wireless stations. For example, in Belgium we have an iPad school, so where all the children have to use iPads, so they have to connect to the internet to do exercises. So that's the trend, so we will have to find out what is the exposure from these devices in schools. In creches where also Wi-Fi installations are done, and homes, of course, children also staying in homes. Campaigns were done from September the 10th in 2010 until March 16, 2012. Campaigns have been done in Belgium, but also in Greece. So we collected all the measurements together in one data set. So I will present the measurements in Belgium and in Greece. I split it up here between Belgium and Greece just to give you an idea if there would be a big difference between the two countries. So we also selected schools, creches, offices and homes in rural areas, in suburban areas and urban areas, just to find out is it in rural or in suburban or in urban areas where we found the biggest exposure. Per location we looked at maximum 2 rooms, so we did observations in the schools, for example, just to be sure that we would be in the room where we expect maximum exposure. And per room we did minimum 1 narrowband measurement that was with that complex instrument. So 153 measurements were done, which is quite limited, but if you can imagine that we need at least a half day for one school. So if you can imagine 153 measurements to be done, it takes a lot of time. And so I hope we have some continuation to do more measurements. But I can already say that we have sponsoring from the national government in Belgium to continue to do measurements in schools and in creches, because it's people in the schools, directors of the schools are becoming aware of this issue, and so they want to have knowledge about the fields from the wireless sources in their schools. So, the measurements then. The measurements, what I show you here is 2 graphs, one from Belgium, one from Greece. So these are the creches in Belgium and in Greece that we measured. I told you already that we have background. Background was fields from all the antennas outside the school, so from TV, GSM, radio. Then these are the stations in the creches, the Wi-Fi stations in the creches, and these are decked, so wireless phones are also used in Belgium and Greece very often in creches, in schools, in homes. So that's why we also included that in the measurements. Then to explain the values, so remember that we always measured in the schools at the maximum, where we had the maximum exposure. So we always measured there at the maximum location. So it's a kind of worst case that we measured. And then if I show you here the maximum, that means that it's the maximum over all the creches. If we show you the mean, that means it's the mean value, the average over all the values in the creches. So what you see here, so this is the maximum for the background, it's 1.2 volt per meter. If you compare it here, I think the limits here in Switzerland in schools are about 4 volt per meters. And so we found here 1.2 volt per meter, Belgium 1.56 volt per meter for Greece, which is lower than the limits here. In most countries, the limits are even higher than this 4 volt per meter. But if you then compare it to Wi-Fi and to DECT, Wi-Fi and DECT, especially in Greece, they have much lower contribution than the background, which is also the case as in Belgium. Even if you look at the mean values, you see it's a factor of 2 less in Belgium and even a factor of 6 lower in Greece. Okay, these numbers itself, if you will do more measurements, we will have less, there may be less deviation between the countries, because then we will have more measurements and we can take more trustable averages over all the creches that we are measuring. But it gives you already an indication that the contribution of Wi-Fi and DECT is lower than the contribution of the outdoor sources. The same for schools, even there it's even more pronounced, that you can see the maximum values for the background in Belgium and Greece is again comparable, 1.6 volt per meter, but here the Wi-Fi is even much lower than in comparison to the background. So we found here the same conclusion, that the background is still dominating with respect to the Wi-Fi sources. But of course we also have to accumulate these sources. We have to accumulate the background with the Wi-Fi. So anyhow, if you install Wi-Fi, it increases the exposure at those locations. Okay. Then I give you maybe an interesting graph where we measured close to a Wi-Fi base station. And then you see, if you go very close to a Wi-Fi base station, the fields are quite high. They go up to 3 to 5 volt per meters. But that's really if you would nearly touch the Wi-Fi station. But it goes very fast lower. And then it ends up a little bit on a nearly constant value. And that's because of the influence of the environment. So within the room, you have a nearly constant field, and that's in some sense good. That means that you can move your laptop from one place to another. You still are receiving the same kind of field value. But it gives you an idea that if you have a Wi-Fi station, but it's the same for a DECT base station, it gives you an indication that it's better to move it away 1 meter from where the people can sit. So if you have an office at home with a computer and next to it would be a Wi-Fi station, position it 1 meter away, then you are sure that you are at the lowest, much lower level than closer to that base station. Okay, so once we know the fields that are incident on the people, we have to determine the fields in the people. And the measure for that is the specific absorption rate. It can be derived from the electric field in the body. So the field outside the body is not sufficient. We have to determine the field in the body. Unfortunately, I'm still waiting for candidates to have probes implanted in the body to measure the fields in the body. So if you would be candidate, please come to me after the sessions. So unfortunately, we have to do some predictions of the fields. We cannot measure in the body, not yet. Maybe in the future we will be able to measure non-invasively, they call it, the fields in the real body. But nowadays we help ourselves either to measure in phantoms. These are just replications of human bodies, but it's just like it's simulations of the human body filled with liquid. Or we can do also simulations, and we'll show you this part, the simulations that we have done. So there are two different limits for the SAR. So there's the limit for the SAR that is average over the whole body. I call it here whole body SAR, but remember it's averaging over the whole body. It's 0.08 watt per kilogram, but you will have to compare it with 80,000 microwatts per kilogram, because I will express my values in microwatts per kilogram. So that's the conversion to that dimension. The second quantity is the maximum of the SAR averaged over 10 grams of tissue. So what we do is, so we calculate the SAR inside the body. It will change from point to point in the body. And then we average it over 10 grams of tissue. So we position a 10 grams of tissue somewhere, and so we average then the SAR over that 10 grams. And what is the limit then saying? Because in the head and in the trunk of the people, we have the most sensitive organs. So that means that there the limit is more strict. So we have 2 watts per kilogram. While in the rest of the body, it's 4 watts per kilogram. So I call it here the local SAR, but remember it's the maximum. So it's the peak of that SAR averaged over any 10 gram of tissue. Okay, so we had the crashes. And now I have placed a 1-year-old child placed at the maximum location, at the maximum of exposure in that crash. And then we can calculate the whole body SAR, so the SAR averaged over that 1-year-old model of that 1-year-old. And so what we have here is the maximum here is, and that's for the background, is 60 microwatts per kilogram. So that's certainly, it's more than 1,000 times lower than the limit. So I think it agrees with what Professor Kuster is saying, that the base station itself are not really the issue. It's more the sensors, more the devices that are placed on the body. Okay, so what we did is then we also calculated in models the SAR, the local SAR, and so with devices placed on the body. So you see the different locations there, because it could be in a backpack, etc., and in also jackets, pocket, side bag, and so different locations, different positions. And well, I will come to some conclusions. Is that that in principle it's increasing with higher frequencies. So if you have GSM 900 and Wi-Fi 2450 megahertz, the local SAR is 3 times higher, but the power of the devices is only 10% of the power of the GSM. So typically, the local SAR for Wi-Fi will be 30% lower than for GSM 900. And farther from the distance, it will decrease rapidly. So if you have a very large distance, so a large separation of the device from the body, so larger than 20 millimeter, the local SAR will decrease very rapidly. But will also depend on the body composition below the antenna. And finally, I will want to demonstrate just one, the web-based exposure tool, because I think it's interesting to show that. So this is the tool that we developed. So it will be, well, so you will be able to draw the grand plan of your house in that tool. Quite simple. So if you have children, certainly they will. Certainly able to draw this plan, but we worked with groups that are working on user-friendliness of interfaces. And so you can draw your plan, you can draw the doors in your, you can also draw the windows. And then, when that's finished, then you can position the access point if you want, if you know, but you can ask also your provider where the access point is, and then you can calculate the whole body SAR based on the models that we have made in the project, and also the field. So here you can also see that it's also good to position the Wi-Fi access point in a location where people are not really present. So for example, in the garage, not people are always present, so there you can also position the access point or ask the provider to position it there. So that will be available as we have a tradition in Belgium of multi-languages, so we will translate also the web tool in different languages.
And there were 2 groups involved in looking into the biology of this, and one team was located at Fraunhofer in Hanover, and one was our team in Basel. And so, and of course, you can never avoid ITIS. ITIS was involved as well. So, in order to introduce genotoxicity to you a little bit, I have to go give you a crash course on genetics or molecular genetics, very briefly, to stay within the 15 minutes. You probably know that we're all encoded by DNA, and DNA is in cells, and the DNA is a linear molecule that is made up of 4 building blocks, and the sequence of those building blocks encodes genes. So it's a bit like digital code of music or movies or whatever. So and there are many genes, and there's a lot of DNA in our cells, and as I say, this DNA has to be decoded, translated into proteins, and the proteins is what if you go away, then I don't expose you to radiation here. So the proteins is what actually provide the functions and structure of our bodies. And so it's the DNA that we were interested in. The trouble of DNA is it's a relatively unstable molecule, and it's easily damaged. And it's damaged from a variety of sources. I'm sure you know all the dangers of these kinds of things for the DNA and for the genetics. And there's a lot of damage to DNA. So having damaged DNA in cells is nothing unusual. Each individual of our cells suffers maybe 50 to 100,000 times damage every day, and most of it actually comes from metabolism itself. It's oxidative damage, and that's not so much of a problem because we've learned to deal with this, and the reason we can deal with this is that we have systems in our cells that repair the damage. So they detect damage in DNA, and then they make sure it's removed, and it's removed in a way that no mutations occur. So obviously the question has been whether magnetic fields of any kind would be able to damage the DNA as these other things do, and in that sense sort of threaten the stability of the genomes. But I have to say, we have to always be aware that life itself is extremely genotoxic. And so if damage happens to be not recognized by the DNA repair systems, then what might be happening is that it is converted into mutations. And that's not the same thing as genotoxicity. So genotoxicity just describes the damage on the DNA. Mutations is a conversion of damage into changes in the DNA sequence or aberrations in the structure of chromosomes that may then alter proteins, and the alteration of proteins ultimately can lead, but must not necessarily lead to a phenotype. And it's actually a good thing that we can change DNA because that allows us to evolve, allows us to adapt to changing environments and so on and so forth. But sometimes if cells in our body evolve too much and too rapidly, what we may end up with is a cancer. So that's why genetic instability and DNA damage is sort of a concern because it may lead to cancer in some cases, but it doesn't have to. So basically the objectives of our part of the projects were we wanted to assess genotoxicity of wireless EMF signals by standardized and accepted tests, using those tests that are in the domain and that can be used. And we wanted to do this in human cells, and we wanted to do this in cells from mice that were exposed to those signals. And I'm not only always going to explain the signals, Jürgen has done that. We have used the signals he has introduced to us so beautifully. So, and then we wanted to combine these standard techniques with more advanced techniques of genotoxicity testing in order to increase the sensitivity of these tests and see if we can see something. And importantly, in case we would find positive results, we wanted to repeat the identical experiments in both laboratories in Hanover and in Basel to see whether those things are reproducible. And finally, we also wanted to develop novel technology that will allow us to go into the study into the mechanisms of these potential genotoxic effects of the magnetic fields. Altogether, obviously, should enable us to do a better risk assessment of these fields and actually give the biological relevance to everything we've heard before. Right, so what kind of methods can we use to detect DNA damage? So we have, on the one hand, we have the models. I already said we wanted to study cultured human cells in vitro. And we wanted to study cells in vivo when they're exposed in vivo. That means in mice, basically. And from the mice, we took the blood cells, we took bone marrow cells, and we took keratinocytes. And then we wanted to study those things with the COMET assay. I'm not going into detail what the COMET assay does. It's just a way of measuring the occurrence in cells of DNA strand breaks. So when these linear molecules break, then that's something you can detect with a certain sensitivity, not all too great sensitivity, but with a certain sensitivity by this assay called COMET assays. And then we wanted to use micronuclide tests, and that's a test that basically measures the occurrence. If this is a cell and this is a nucleus here, and that's the genetic material. So this test measures the occurrence of these aberrant structures, obviously also containing some DNA, some genetic material, and that's an indication that something has happened to that DNA, and there might have been, some sort of instability inside. Doesn't necessarily have to be damage. Can be DNA segregation problems and all sorts of different things. Right, so now what we find is, this is just now going into the human cultured cells in vitro. So we take these cells, we culture them in vitro, and then we expose them to those fields, and then we evaluate the comets, and we do this always blinded. So when we do the experiment, we don't know whether the cell, the control, which of the two cultures we do in parallel is exposed and which one is actually the control. We always learn that later on. And then we do the, as in this particular case, we do the experiment in Hanover or Basel. I don't even actually know which is which in this particular case. But what you see is, if we then measure those percentages of tail in the comet, percentages of DNA in the comet tail, which is the factor of damage, DNA damage in this population, what we see is we have no difference in this with this particular signal and this particular cell line. We have no difference between exposed and non-exposed. So, and that's been reproduced in both labs, and that's fine. So that's an experiment we can accept. Now, this is the whole lineup of such an experiment, and that's one from Fraunhofer in Hanover, where you see that we're looking with this cell line for the whole spectrum of doses here. So that's an UMTS signal, SAR doses, and time of exposure. And all you have to look at here is those columns here, the black one here and black one there. That's exposed, that's not exposed, exposed, not exposed, exposed, not exposed. And what you find, if you look at it through this, there's no effect. There's no effect at all. What we have is effects in the positive controls. These are controls that we always do. And we have no effects in the exposed and jam. And if we use such an advanced test that is a bit more sensitive and shows us whether there might be specifically oxidative damage, same picture, no effect. So we can't see any effect in this particular experiment. If we summarize it all, this is all the experiment we have done, the cell lines we've used, the signals we have done, and then the coverage of the experiments. And the conclusion from the COMET experiments basically is that we have no evidence that exposure to these high-frequency wireless electromagnetic fields causes DNA damage that is detectable by the COMET assay. Right, then the mouse experiment, that's a bit busy, and I don't go through this, but this just shows you basically the study design, how many mice we used for which signal, for what signal, and it's the design of how we exposed and how we measured effects in the mice. So these mice are exposed while they're of course alive, and then they're sacrificed, and the blood cells are looked at, the bone marrow cells are looked at, and the keratinocytes. So that's basically how it works. And in this case, it's the micronucleus test. So looking for these funny little bodies in the cells that indicate DNA aberrations. And when we look at that for the 4 signals that we've tested, and that's a Fraunhofer experiment as well, we find that UMTS, Wi-Fi, and RFID and CV have essentially no effect. There is one exception here where we seem to see a significant increase in the blood cells. That's the red blood cell example. I'm not going to show you all the others, the keratinocytes and the bone marrow, because there was no effect at all. But in this particular case, we have a little bit of an effect here. It's statistically significant for UMTS at the highest dose, and that's something that needs to be further looked at. So basically, but the conclusion from these experiments is that there is no effect from the micronucleus formation of UMTS, Wi-Fi, RFID, and CV exposure, but we have this exception of this little peak here, and that's something that needs to be addressed again, needs to be replicated, needs to be looked at in more detail. Right, and then I'm coming to development of advanced technology to measure, and that's the second last slide. I don't know how I'm doing with time, but so this is a fancy and useful little thing that we have generated together with ETs, of course. So what we do is we have a microscope first of all, and that microscope can be used to look into living cells and monitor behavior of living cells while they're under exposure. And to be able to expose cells on that microscope, we use that chamber, and that was developed at ITIS, which we can put on that that's the microphone. We can put on that microscope and then look at the cells. And the kinds of things we can look at is the dynamics of processes, of cellular responses to the exposure of the field. And that's an example of what we have done. In this particular case, we're looking at the nucleus here of a cell. That's where the DNA is. And then we have this DNA repair protein, which carries a green fluorescent protein, but is still functional. And then we damage the nucleus here with a laser that does induce UV damage. And then we measure simply the time of the timing of the recruitment of that repair protein to the site of DNA damage. And the question we were trying to address is whether the field exposure does, in fact, affect such dynamics and kinetics of cell physiological processes, amongst which may be DNA repair process, but it cannot only be used for that. And you see, if we use an inhibitor of that repair process, the recruitment of the protein into the site of the DNA damage is much slower. So that's the point, is we can record all these behaviors here, and we end up having a quantitative result which tells us whether the field affects any sort of cell behavior or response to DNA damage. Right, and then I'm coming to the conclusions. Okay. So our first conclusion is there's no significant effect of wireless EMF exposure in standard and advanced COMET tests with cultured human cells, and that concerns GSM, UMTS, Wi-Fi, RFID. From all those experience with these experiments and previous experiments that we've done in the context of the NFP 57, we can say with high certainty exclude that these fields do induce direct physical or chemical DNA damage. I think that's a fairly certain conclusion we can draw. You can never prove an absence of an effect, but that's probably as close as we can come to it. So then, no, there's also no significant effect of the field exposure on micronuclei formation in mouse blood and bone marrow cells, as well as in keratinocytes. And again, this concerns all the four signals. And I'm separating this from the DNA damage thing because it's not quite clear whether the micronuclei, they actually would reflect DNA damage. There is this one exception that I mentioned with the UMTS on the highest dose, and that's something that needs to be looked at again, and that's something we will be doing, especially also to be sure that we're not looking at terminal effect because the dose was relatively high there. And then we have established and available the advanced methodology to study mechanisms associated with responses of cells to EMF exposure. Right, and I would like to thank you, and this has been an awful lot of work and an awful lot of people have been involved, and I would like to thank them all for a great job and you for your attention. Thank you very much.
And good evening. It's certainly a pleasure to come to this beautiful part of Switzerland. However, we spent the last 3 days in this room, so I never got a chance to really see the mountains during the daytime. I understand we'll be there again tomorrow. But I'll be talking about risk evaluation and risk governance. And risk is something we all know because we make risky decisions throughout our lives. So when the stock market's low, we say, should we invest in stock? That's a financial risk. And if the stock market goes up, we say, wow, we're very smart. But if the stock market goes down, we get very angry. But I'm not going to talk about financial risk. I'll be talking about environmental health risk. And this I'm defining as the likelihood or a chance that there's an adverse health effects occurring, or they might occur in people or populations that are exposed to a hazardous agent. And risk governance, then, is part of a decision-making process. This involves assessing and developing some type of regulatory action and evaluating the consequences of those actions or alternative actions. So a decision maker obtains the information from a risk assessment and has a variety of options that they can make to decide what would be the best approach. So I want to continue on to determine how do we get to the point of a risk governance decision. So we'll start off with the standard approach, a risk assessment, risk management approach. Well, first, you need to identify a hazard. This would be an agent that causes an adverse effect, whether it be in people or in animals. It's an adverse effect that has been identified with an agent. Secondly, we need information on exposure. This would be an exposure assessment. What are people exposed to with respect to this agent under different conditions? So it may be whether it's electromagnetic fields. Is it from using cell phones? Is it from the outside environment? What are all the exposures that people encounter? With this information, then you can develop what is called an exposure response assessment. What is the relationship then between that exposure in people and an adverse effect that might occur? And finally, there is the risk characterization. This would be to understand what might be the risk under a variety of exposure conditions. So there may be some people in an occupation who are exposed to high levels of an agent, but there are also environmental levels which may be lower than the occupational exposure. And for regulatory decisions, there's an acceptable risk that people might be willing to tolerate because of the benefits of the agent to which causes an effect. So we can characterize, this would be a potential health effect that might occur at a variety of exposures and try to determine a level, say, that might cause this particular disease effect in 1 in 1,000, might be 1 in 100,000, 1 in a million. Depends on what is considered to be an acceptable risk. This information then is handled separately. It goes to a risk management decision to decide what should we do about the situation when a risk is identified and we've characterized the relationship between exposure and that risk. So how do we start off and identify a hazard? Well, one approach is from animal studies. This has several advantages in that a very precise exposure condition can be defined. The effects of an individual agent are clearly identified. When we're walking around, we're exposed to thousands of different agents in our environment. How do we pinpoint a specific agent as being that hazard? However, animal experiments must be adequately challenged. If we're looking to identify a hazard, must challenge the hypothesis, the null hypothesis being that an effect cannot occur. So you challenge in an animal study to see if there is a hazard. But the disadvantage of an animal study is that it requires an extrapolation to people. And an animal may behave or respond differently than people, and often in animal studies, the exposures are higher than typically found in the environment or even sometimes occupational exposures. Another is through human studies. The advantage of a human study is these are based on the real exposures to humans. There's no species extrapolation. However, there are certain concerns that must be taken into account. Was there a bias in terms of determining what people were exposed to who had a particular disease? Were there confounding factors? Well, if a certain disease occurred, was it the agent that you're looking at, or was it another agent that people are also exposed to? Frequently, the exposure measurements are imperfect. So when we talk about exposure and a disease, do we know precisely what people were exposed to when they developed that disease? These are past exposures, and they may not reflect current conditions. And this type of information is very pertinent to the issue related to cell phone radio frequency radiation. And also, with respect to human studies, oftentimes data are not available from susceptible subgroups. Many cases, these are occupational exposures, or they're exposures, for example, of adults. They may not include children. Or if there's a genetic disposition, they may not be identified as such as a susceptible subgroup. And thirdly, there are mechanistic studies, as Primo was mentioning, and these may support or refute the biological plausibility that a disease event has occurred, because mechanistically it makes sense, or mechanistically it does not make sense. So within the Seawind project, there wasn't an identifiable hazardous effect that was observed such that a risk assessment could be performed with these data at hand. So what I want to talk about is something that may be a little more familiar to some, was the evaluation that was performed by the International Agency for Research on Cancer. This is part of the WHO. And as mentioned by Niels initially, the evaluation of radio frequency radiation, which I'll be sometimes referring to as RFR, from mobile phones, was found to be possibly carcinogenic to humans. Now, this is probably an answer you don't want to hear, because what does possible mean? Is it or isn't it? People want to hear, is it black or white? The gray area adds a little bit of confusion. So I want to walk a little bit through how this conclusion came about and what it really means. So there have been animal studies with radio frequency radiation, and the evidence within the animal studies was considered by a working group of IARC to be rather weak. However, most of the studies lacked sufficient power or challenging doses to find an effect, if an effect would occur. The National Toxicology Program, from where I came, is conducting very large studies at this time at much higher exposure intensities, many more hours per day, and these studies are in progress, and hopefully when they come out will give us a better sense of whether there is the plausibility from animal exposures to an effect in humans. From a mechanistic perspective, no established mechanism has been identified other than a thermal mechanism. Radio frequency radiation is non-ionizing, and as defined within the Seawind project, there's no evidence of direct DNA damage. DNA damage would obviously be a concern for a cancerous event. Okay, so how did IARC come to the IARC working group come to evaluate radiation from mobile phones? It was based largely on human studies. There were two major human studies that reported elevated risks of glioma. This is a tumor of the brain. These are cells that support the neurons. There was also elevations, so these were significant, of acoustic neuroma. This is the covering of the auditory nerve in the ear. But there was no evidence of increased risk for meningioma. These are the coverings of the central nervous system. Now, how did they come up with these conclusions within these studies? The exposures of brain cancer patients and matched controls were determined based on a recall of their past mobile phone use. And these were based on interviews and questionnaires. They were trained interviewers to ask people who either had the brain cancer or the family, if it was a death related to the brain cancer, what was the use of the cell phone, mobile phone, of that individual. Now, this obviously lacks the precision that the Seawind project is providing in terms of exposure. The kinds of information they would obtain would be, when did they start using a cell phone? How often did you use the cell phone? When you're on the cell phone, how many hours a day were you using your cell phone? And the two major studies, one wasn't called the Interphone Multicenter Study, was based on cases that were examined between the years 2000 and 2004. And within the highest exposure group, and at that time, up to 2004, the highest exposure group had cumulative hours of exposure of 1,600, which is, probably in today's day, much less than many people are making use of their mobile phones. There were also studies in Sweden that were examining cases and matched controls between the years 1997 and 2003. And in that case, the highest exposure group was 2,000 hours of cumulative use. And the risks in that study were increased with latency. That is the time from when they first used a mobile phone to developing this cancer. And this is what you might expect with a cancer, because cancer does have a latency. Also, they asked the individuals, which hand did you hold your mobile phone with? And the risks were higher on the side of the head of that reported use. So what did we do with these results? When you're dealing with questionnaires and interviews, there is the possibility of bias in terms of people reporting their use. If you have a tumor, you might be prone to say, that's the side of the head in which I held the cell phone. I used it more frequently than someone who was not a case. So what do? There is that potential for bias. Do we dismiss these findings? Say, well, it's possibly due to bias, or are the effects possibly causal? Okay. IARC has defined the definition of limited evidence of carcinogenicity in humans. And this is when there's a positive association has been observed between exposure to the agent and cancer for which a causal interpretation is considered to be credible, but chance, bias, or confounding could not be ruled out. That would be the IARC limited evidence. If you could rule out bias, chance, or confounding, that would be sufficient evidence. This was the level of evidence that was considered to be pertinent to the mobile phone radiation. Limited evidence, then, by IARC standards, is equivalent to possibly or probably carcinogenic to humans. The working group felt that because of issues of possible bias, possibly was the more relevant classification for radio frequency radiation. Now, there are other issues that are also important with respect to radio frequency and cancer risk. One is, what is the effect of phone radiation on the developing fetus and on children? We don't know. However, we know that with exposure, holding a mobile phone, a child's brain will see a higher exposure, and also a developing brain will be more susceptible to an insult than an adult brain. As I mentioned, the number of cumulative hours that were included in those epidemiology studies are small compared to what the cumulative exposure is now. So what it would be the effect of longer term use, those were up to about 10 years. Now we're into about 15 to 20 years. What might the risks be? We don't have the answers to that as with greater cumulative exposure. Question might be, are brain cancer rates increasing in the general population? Well, this has been looked at in the US and Denmark, but it's only with 15 years of general use, and brain cancer latency could be as long as 20 to 30 years. So we're still not sufficiently at the time to know whether there is an elevation in brain cancers in the general population who use their mobile phones to a large extent. And as I said, mobile phone use has been increasing markedly. Another issue is that there's been a changing in technology. We started off with the analog phones, 2G, 3G, 4G. The Gs will keep increasing, and it's a function of the change in the types of signals that are emitted. Another is the location of the antenna. Mobile phones have changed. The antenna is not as close to your ear as it is to your chin, where the antenna has been moved away from the brain. And people are exposed to more than just radio frequency radiation from mobile phones. There are multiple wireless network devices. These exposures have now been characterized in the Seawind project and provide a much more accurate assessment of what are the exposures. So now we come to the last phase. What are the risk governance options? Well, based on the information at hand, one option is do nothing. Say, we don't believe it. Another, ban the use of mobile phones. Someone suggesting that would probably be putting their life at a risk. What about reducing the allowable standards of exposure? There are standards for which phones are allowed to emit radiation. Maybe these could be reduced. The other is to encourage precautionary steps. And some of these are reduce the time of handheld mobile phone use. Use hands-free devices that would keep the antenna away from the head. Limit the use of mobile phones by children, and promote the reduction of radio frequency emissions from mobile phones and other wireless network devices through technological advances. And also support research on what are the potential health effects of radio frequency radiation from these multiple network devices. And as I showed earlier, exposure assessment is part of that component. The Seawind project has provided that. What are the health effects now that are associated with a better measures of exposure to radio frequency radiation? I think.
So, but according with the organizer, we have plenty of time for the discussion. So please start with your questions. If you request some comment or other additional information or explanation, please feel free to start. Yes.
Why are we only interested in
Just wait for the microphone.
Why are we only interested in cancer? There are many other things around.
Yes, biologist or the coordinator, it's up to you.
So the project, as mentioned, was 3 years and 3 million. So and the main focus was on exposure assessment. So most money was spent on exposure assessment. And there the minimal amount of the resources could be placed on biological experiments. And here we decided to do this double check to check if this slightly different kind of exposure has a different effect than what we have investigated for the mobile. And of course there are many other endpoints which could be investigated, but the program, the limitation we had to work with didn't allow us to do.
It's up to you.
Allora io parlo italiano, volevo sapere, avete fatto studi su eventuali cause come il cancro e problemi neurologici?
Okay, the lady asked if we have some data on neurological effects or if we are involved in some studies on neurological effects.
So we actually have specialists here in the audience who are doing research on brain. So maybe may I ask Peter to, if he is here, is he hiding somewhere?
Yes,
Yeah,
yes,
he's
Peter
over
is
there.
just.
Peter is here. So maybe he can report what has been done and should be done.
So there have been several projects investigating the effect of radiation on the brain.
Peter, can you stand
mainly-
up? Just the people can.
Okay.
Yes, thank you.
So mainly looking at the effects during sleep. So is sleep affected by exposure to radiation? And the basic results are the quality and structure of sleep is not affected. Basically what we see is a change in the brain waves, but brain waves are affected in many ways. But exposure to electromagnetic fields also affect brain waves, as a cup of coffee would do as well. And it's difficult at the moment to assess how dangerous this would be. So we have to understand what's really going on in the brain if you are exposed. But I would say at the moment we don't have an indication that this is critical. But we need to do more research to understand what are the biological mechanisms leading to a change in brain activity.
Yeah, we had today a full session on this topic, and we concluded that the changes what's been observed in the EEG is one of the effects which is reproducible in different laboratories, and we're convinced there is an effect, but we do not understand the effect yet.
Altri 30 anni e 30 milioni per lavorarci.
Let us look first at the base station antennas from the operators. Each base station antenna is serving an area where you can phone. Within that area, the operators want to have the same signal everywhere within that area. So normally the electromagnetic fields are decreasing with distance. In fact, proportional to the 1/d squared distance. But they try to compensate it by sending more radiation to farther laying points on the ground, so that people in farther laying points on the ground have the same kind of signal. So in fact, it's the device, it's the mobile phone who determines which signal should be there. Of course, it's not an ideal situation. There are trees, there are buildings. So in some places you will have higher signals, and in other places you have lower signals. There where you are receiving lower signals, your mobile phone will have to send more power to the station. So anyhow, it's always better to phone in conditions where you are better receiving also the signals. So that's I think the first part. In indoor devices, there it will, as I was showing, it will rapidly going down because of all these reflections in the room. Look at here, a lot of tables, etc. There will be a lot of reflections, and you get quite constant around the Wi-Fi station, but it will not go through the walls. It will be difficult to go through the walls, especially in Europe and in the States. I think it's going easier to kind of wooden structures than here we have more concrete structures. So if you're in the garden, normally you will receive less signal than from your indoor station. But of course, it should be cumulated with all the background, as I explained, background radiation from the other stations outside the building. So, so distance alone is not a good measure. So that's why limits, if the government have to put limits, it should not be the distance from the antenna, it should be the field levels, for example, in schools should be limited by this level. Not saying that the antenna should be at this distance, because if it would be farther, they would put higher power on that antenna just to have the same signal level. The good thing with new technologies is that the devices are more sensitive, so they can work with lower levels. But of course, if there are more antennas, it's just accumulating. So that's if you have Wi-Fi, if you have GSM, if you have UMTS, all together, it will accumulate and accumulate. So, and more information will be sent.
Che non ci sono come posso dire, evidenze scientifiche al momento che queste tecnologie creino dei problemi al nucleo della cellula, al DNA, eccetera, eccetera. Però d'altra parte date consigli per come subire meno influenza. Quindi a mio avviso tutti voi avete il dubbio che qualche problema lo causi veramente. Voilà.
Il dubbio fa parte del lavoro del ricercatore e il dubbio è nella scienza. He asked if some of us have children, and if we have children, if we allow them to stay on the telephone, if they have telephone, and what do you think really in a deep part of your heart about the health and telephone. So start with yes.
It's short. Okay, this is an interesting evening. You are probing our psyche and morals, but for the evidence, in my case, this epidemiological and mechanisms and so on, various results you heard about today, I don't think there is a biological effect. This is just my gut feeling, my opinion. But I'm willing to be convinced if I see some good evidence. And I'm a little worried about the heavy users after 10 years. So there is something that we have to think about and follow closely. But up to now, I don't think there's if there was a serious problem, I think we would have seen it already.
Mm-hmm.
Next.
Yeah, I have 3 kids. And personally, I mean, there's obviously no evidence for me to, I couldn't make an evidence-based judgment and say, you don't use the mobile phones, or I don't use the mobile phone. So in the absence of evidence, I do what we've heard as well. I do precautionary measures, so I can say, if there is danger, I can't prove it, I don't know it. We need to look for the antennas, we need to look for effects, we need to perhaps also consider things that we have heard in the discussion, the more complex, the complexity issues as well. But so what I can do in this situation is I'm trying to look for things, and I'm upfront with my kids and say, I don't know if it's dangerous or not. I get that question a lot, and say, if you're afraid it might be dangerous, and I would recommend that just use it as little as possible. And just be reasonable in the way you, I mean, use the distance, shut it off in the night, and just be reasonable in the way you use it. And you know what counts, it's distance, it's time, it's that. And that's what you can limit. So precautionary measures. And that's my personal behavior as well.
So I have 2 kids, one of 12 and one of 14. And at that age, if I would say something, they would certainly oppose against what father is saying. So they are so used to these devices. They're using it differently. That's, I think, already, they're using it more for SMS. than for phoning. They are not really phoning anymore. So I think they are holding it not anymore so close to the brain. But again, I started, for example, because it's not mandatory to wear helmets on the bicycle. My first mission is to help them or to ask them to wear the helmet, because I think a helmet is maybe much more important if they would fall from the bicycle. And I think the brain damage could be much higher than from the mobile phone. But again, I think longer term, it's good to be if they could take some measures. But even adults aren't doing that. So I was in the parliament in Belgium, and lots of people say, "Well, we are against against the radiation from mobile phones, not against mobile phones." And then I ask who is wearing these ears, just the wires, just to connect to the mobile phone. Nobody is using it. They don't want to use it. So how can we convince children if they... But I really believe that, first of all, more information should be given in the schools. There's no education in the schools on mobile phones. They learn to work with computers, but they don't learn to work with mobile phones. And that's why we do the measurement campaigns. That's why we try to work with the schools to make informations on what is electromagnetic radiation. How can they take measures? I think themselves, they should be taking the decision from themselves. But I would also be in favor to limit it at a certain age, because we see more and more younger children using it. It started some years ago, it was at 10, and now it's already at 7 that they start to use mobile phones, and maybe later on it will be from 5. And even there are applications on the mobile phones, which are attracting children of 2 or 3 years already to use these devices. So we have to think about this. Is indeed a society question, but we as we are looking at the effects. We don't have impact on the use of these devices. It's not our task. It's for society researchers, and about the governments have to take the decisions, not the researchers have to take these decisions.
So I have 2 children and 3 grandchildren, and I'm a public health scientist. So I'm sorry. I told you I had 2 children. I did. It's probably the best. Okay, I'm a public health scientist, so I take public health issues quite seriously. I have 2 children and 3 grandchildren, and my advice is use a Bluetooth when possible, use a speaker system when possible, because a lot of the work that developed initially was observed in the Swedish studies finding brain cancer elevations. And as a consequence of that, the WHO wanted to explore this issue much more thoroughly, and the studies were not negative. There are limitations in the studies in terms of issues related to dose response and a number of factors. But when there is a significant elevation in brain cancer with 10 years of use for a disease which could have a 30-year latency, and the amount of use is increasing so dramatically from the time in which those exposures periods were evaluated, we don't know right now whether the predictions can be made. Will there be an elevation in brain cancer risk? Reliable predictions could be made and examined. Right now, the elevations are not apparent over the first 15 years, but that's a function of how much use there was in the population in that period and that latency period, whether it was adequate to detect a significant increase. So my advice is be precautionary because it's not necessary to hold the phone next to your ear for 4 hours a day for your children, holding that phone next to their ear. Spending time on it to find out if their friend, passed a course or whatever. But I would limit the use by children. There's no data on what the health effects might be on children. Their exposures will be greater than that of an adult, and a developing system is more susceptible. So when you don't have answers, you're playing a risky game. You might be right, but you might be wrong. And to me, the consequences of being wrong outweigh any other consideration.
Particular questions or comments? I would like to thank first the audience, and then all the speakers, and we are happy to have the possibility to know the data of the new project. Thanks a lot for your participation.